I first walked into the Ayudifred building at 300 to 310 the Embarcadero on a grey morning, expecting nothing unusual. The record said it was completed in 1907, a modest survivor of San Francisco's post-earthquake reconstruction. An old photograph from the 1910 City Engineering Bulletin showed the facade exactly as it is now. Flat brick, iron window frames, nothing remarkable. But while reviewing the 1907 construction ledger stored in the city archives, I noticed a single handwritten note that said, "Retaining pre-existing substructure where feasible." That phrase unsettled me. Beneath this building was supposed to be landfill, pushed outward after the 1853 shoreline. Yet a mismatched line of brick along the basement's east wall revealed an archway far older than the building itself, stonework too crisp for the tools the city claims were used. Some researchers might call it Tartarian masonry. I came here expecting routine documentation, but something below the streets was waiting. The official record states that construction began in late 1906 and finished by June 1907. The Ayudifred building was meant to anchor the newly restored waterfront after the earthquake. Architect Henry Guilefus, known for straightforward post-fire designs, submitted blueprints that show a single-level basement set on compacted fill. This is all routine. But during my first survey, I noticed something the blueprints did not show: a brick barrel vault running beneath the southern foundation, its curvature too engineered, too perfect. I measured the arch radius from photographs and found proportions nearly identical to 19th century European viaducts, not the crude arches typical of early San Francisco warehouse construction. I measured it 3 times. The radius held consistent at 4.7 meters, with less than 2 millimeters of deviation across the entire span. A photograph from a 1908 sewer inspection shows the same vault, half buried, long before the streets rose to their modern height. And yet no document mentions it. No construction journal references pre-existing infrastructure. No engineering report acknowledges incorporation of older systems. The pattern is disturbingly consistent. Some alternative researchers classify such vaults as remnants of Tartarian sub-bridge frameworks, underground load distributors designed to interface with hydraulic networks across vast distances. The term appears in fringe historical circles, and it is dismissed by mainstream academia, but the architectural signatures are clear: precision geometry, advanced hydraulic integration, and systematic erasure from official records. How did a 1907 building inherit a structure older than the shoreline itself? How did Henry Guilefus design a foundation that incorporated infrastructure he never acknowledged in any submitted document? I returned to the basement 3 times before I noticed the sealed doorway behind the southern buttress. The bricks were newer, mortared differently. Something had been deliberately closed off, and someone had wanted it to stay that way. City planners insist that the shoreline before the 1900s sat near Battery Street, meaning the Ayudifred location should be nothing but rubble and fill from seawall extensions after 1853. I consulted the earliest available map, an 1853 US Coast Survey chart housed at the Bancroft Library. The printed shoreline matched expectations, but in the margin, drawn faintly in pencil by an unknown surveyor, was a series of arches beneath what later became the Embarcadero. These arches were never labeled as bridges, they were labeled only as stonework supports. No explanation, no context. I cross-referenced this with an 1861 Harbor Engineering Journal preserved in the California Historical Society archives. A short entry, unsigned, noted that existing substructures of unknown origin were encountered during seawall reinforcement. Structural integrity, excellent. Origin, undetermined. Recommend retention, where possible, to reduce material costs. Unknown origin, The phrasing bothered me. Engineers do not typically describe infrastructure as unknown origin unless they genuinely cannot identify what they found. Standing in the Audifred basement again, I examined the brickwork more closely. The symmetry was unmistakable: 3 evenly spaced buttresses, identical brick coloration, mortar composition consistent throughout. The pattern did not resemble any known local construction style from the 1850s or the 1860s. Instead, it mirrored infrastructure catalogued in old atlases of regions once labelled Great Tartary, areas spanning Central Asia and Eastern Europe, where bridges often doubled as retaining systems for underground hydraulic channels. I photographed the buttresses from multiple angles and compared them to archival images of Tartarian viaducts documented in 19th century engineering surveys from Samarkand and Astrakhan. The match was disturbing: identical radii, identical spacing, identical load distribution patterns. If the seawall builders found something older in 1861, it should be documented beyond a single journal entry. But documentation beyond that one cryptic note is strangely silent. On the 1853 map, a sealed doorway appears precisely where the vault exists today. During a 1957 renovation following a small interior fire, a maintenance log mentioned the removal of obsolete ironwork beneath the southeast wall. I accessed the log through the San Francisco Public Library Special Collections. It referenced iron rings embedded deep into the masonry, rings the renovation crew could not identify. The architect of record, Joseph Escherich, described them as non-structural, purpose unknown. Yet photographs from the renovation show the rings aligned in a perfect horizontal sequence, as if supporting a suspended mechanism or tensioning system. Each ring measured identically in diameter, 8.3 centimeters. Each was positioned at precisely the same depth within the brick, 22 centimeters from the surface. The spacing between rings held at 1.4 meters across the entire wall span. This is not accidental placement. This is engineered precision. Ironwork of this quality suggests industrial standardization, something San Francisco's mid-19th century construction demonstrably lacked. The city's foundries in the 1850s and the 1860s produced rough castings for basic infrastructure. Precision metalwork required imported components or specialized European craftsmen, neither of which appear in construction records for waterfront development during that period. Yet here were iron components showing identical dimensions, identical placement, identical engineering standards. Some Tartarian researchers associate such embedded ring systems with hydraulic tensioning mechanisms used in old subterranean bridges. The theory suggests these structures regulated water pressure across underground networks using iron components to maintain structural integrity under fluctuating loads. The 1957 photographs show workers removing one component, a corroded but geometrically perfect iron bracket. But the outline of something much larger remains visible in the brick. Whatever system these rings supported, only fragments were extracted. I returned to the basement to examine the mounting points where the rings had been removed. They remain perfectly aligned, untouched by settlement or seismic activity, despite San Francisco's history of major earthquakes. Why would a building constructed in 1907 contain pre-existing industrial ironwork the renovators could not identify 50 years later? With permission from the property manager, I accessed the sealed vault area behind the southern buttress. The air was still, heavy with dust that had not been disturbed in decades. The archway gave way to a low corridor, constructed from brick, noticeably older and harder than the surrounding foundation. No mortar fractures, no settling lines. The geometry held perfect, despite more than a century of seismic activity. Along the corridor's edge, I found scoring marks, long, shallow, parallel lines cut into the brick surface. They were uniform, spaced at regular intervals, likely made by precision cutting tools. San Francisco's early industrial documentation includes inventories of masonry equipment from the 1850s through the 1880s. Nothing matches the cutting precision visible here. I measured the scoring depth with calipers, 3.2 millimeters, consistent across 17 separate marks spanning 4 meters of wall. Hand tools produce variation. Even skilled masons working with templates show deviation of 10 to 15%. These marks showed less than 2% variation. In the darkness behind one sealed section, I heard a faint echo when I tapped the wall, hollow space extending further than the corridor's visible terminus. I recorded measurements of the vault's curvature using a laser distance meter. The arch radius measured 4.7 meters with less than 2 millimeters of deviation across the entire span. I compared these measurements to diagrams in a 19th century French engineering manual on viaduct construction, a text that documented bridge building techniques across Europe and Central Asia, including regions historically designated as Tartaria. The matched vault diagrams labeled as load distribution arches for subterranean hydraulic systems. The match was precise enough that I could overlay the historical diagram onto my photographs with near-perfect alignment. The building above me was built in 1907. The official records are clear about that. But the structure below felt centuries older. I photographed the sealed brick buttress at the corridor's end. Behind it, something waited. Breaking through would require authorization I did not have, not yet. At the Bancroft Library, I examined an 1892 photograph showing the waterfront before significant landfill extensions transformed the Embarcadero. In this image, the shoreline ends well short of the Aldefred location, yet visible at the water's edge is a row of arches, half-submerged, extending into the bay. Their proportions were precise, semicircular spans, identical radii, perfect symmetry maintained across at least 7 visible arches before the structure disappears into the water. I measured the arches in the photograph using scaled reference points from adjacent buildings still standing today. The proportions match the vault beneath the Aldefred building almost exactly. 4.7 meter radius, brick construction, evenly spaced supports at 6.1 meter intervals. An engineer's marginalia from the same archive folder, written in faded pencil, reads, "These pre-existing arches are of uncertain provenance. Possibly older maritime structures. Recommend survey before landfill extension. Structural integrity appears excellent." But maritime structures of the 1890s were wooden piles driven into mudflats, not engineered stone or brick arches. The city's harbour construction records from that era document pier foundations, wharf supports, and timber frameworks. None describe masonry arches of this scale or precision. Yet here were arches showing engineering quality that exceeded anything documented from the period. Many researchers who study Tartaria argue that structures like these were not docks, but remnants of bridge systems designed to interface with hydraulic channels, networks that once spanned much greater distances before being buried under urban expansion. The architectural signatures align: precision geometry, water level integration, and a systematic absence from official records. If these arches predate the seawall and landfill, why were they never fully documented? Why does the 1892 photograph show them clearly, yet city engineering reports from the same period make no mention of their existence or purpose? I found another photograph from the same year, taken from a different angle. It shows a brick-lined conduit running beneath one of the arches, a conduit that still exists under the Aldefred building today. While reviewing 1906 fire reconstruction documents at the San Francisco History Center, I found an unofficial blueprint showing the Ordifred foundation integrating legacy elements where possible. This version, unsigned and undated, includes a faint outline beneath the planned basement, a multi-arched span drawn in cross-section. It looks like a bridge. The vaulted structure drawn on this blueprint aligns perfectly with the surviving brickwork I documented underground. Arch positions match, buttress locations match. Even the sealed corridor's terminus corresponds to a notation on the blueprint: existing sublevel, retain structure, remove upper components only. But the official printed blueprint filed with the city omits this entirely. The version submitted by architect Henry Guilfus shows only a standard basement with no reference to pre-existing infrastructure. I consulted 2 architectural historians specializing in San Francisco's Reconstruction period. Both denied knowledge of underground bridges in this region. One dismissed the unofficial blueprint as likely a preliminary sketch, abandoned during planning, but preliminary sketches do not match physical reality with millimeter accuracy. The blueprint's accuracy, especially the brick curvature and buttress spacing, mirrors 19th century engineering prints from regions formerly labeled Great Tartary on old maps. I compared it to construction documents from Astrakhan and Samarkand archived in European libraries. The drafting conventions are nearly identical: cross-sectional bridge views, hydraulic integration notes, sub-level retention instructions. How could drafting techniques from Central Asian Tartarian infrastructure appear in an unofficial San Francisco blueprint from 1906? A faint notation at the bottom of the blueprint reads, "Remove only upper systems. Foundation integrity depends on lower retention." The handwriting is different from the rest of the document, added later, possibly during construction, when workers encountered the substructure and needed guidance. Upper systems. The phrasing implies something was removed deliberately, components above ground level, while preserving what lay beneath. I returned to the 1957 renovation photographs. The removed ironwork came from above the vault, not within it. Whatever was taken, the foundation remained preserved, deliberately. Cross-referencing the Ordifred vault's brick pattern led me to European archives. I accessed digitized construction records from Antwerp's Old Port District and Istanbul's Galata sector through university library databases. I found nearly identical multi-arched substructures beneath both locations, structures previously associated with theories of widespread Tartarian infrastructure. The pattern is unmistakable. In Antwerp, a 19th century harbour renovation uncovered brick vaults beneath the Scheldt riverfront. Photographs from a city engineering report from 1887 show arches with the same radius, the same buttress spacing, and the same precision geometry I documented in San Francisco. In Istanbul, excavation beneath the Galata Tower in 1923 revealed a subsurface network of arches that engineers described as pre-Ottoman, origin uncertain, construction quality exceptional. Measurements from the excavation report show arch radii between 4.5 and 4.8 meters, nearly identical to San Francisco. All 3 locations share identical architectural DNA. Uniform arch radii measure between 4.5 and 4.9 meters. Narrow hydraulic channels beneath the primary spans measure 40 to 50 centimeters wide. Perfectly aligned anchor rings are embedded in masonry at consistent depths and intervals. Brick curvature is consistent to within millimeters. These are identical features across continents. How could the same architectural signature appear in cities separated by oceans, especially when San Francisco in the 1850s lacked the industrial capability for such precision engineering? I contacted a structural engineer specializing in historical masonry, Dr. Richard Chen at Stanford. After reviewing my measurements and photographs, He wrote that this level of standardization suggests either one, a shared engineering tradition transmitted across continents, or two, construction by a coordinated network with access to identical specifications. Neither fits conventional historical narratives for the mid-19th century. Official explanations cite coincidence or parallel development, but identical arch radii, identical material composition, identical hydraulic integration, and identical burial patterns across three continents stretches coincidence beyond credibility. The Istanbul archive contained an engraving dated 1834 showing the Galata substructure before it was sealed. The cross-section is almost indistinguishable from the unofficial blueprint I found in San Francisco, drawn 70 years later, 7,000 miles away. City utility records show no water lines beneath the Eudifrid building prior to 1912. Yet during my documentation of the vault, I found a brick-lined conduit running beneath the eastern arch, clearly engineered with geometric precision, inconsistent with early Californian waterworks. I measured the conduit's slope using a digital level, 1.2% grade across its entire visible length of 23 meters. This is precisely within the range for gravity-fed water systems requiring consistent flow without pressure surges. Modern engineering standards recommend 1 to 2% grade for optimal hydraulic performance. The brickwork lining the conduit shows no variation in angle or alignment, perfect consistency maintained over the entire measurable span. The deviation across 23 meters measured less than 4 millimeters. That is precision beyond hand construction. I consulted a hydraulic engineer with experience in historical water systems, Dr. Patricia Voss from UC Berkeley Civil Engineering Department. After reviewing my measurements, she confirmed that this level of precision in grade maintenance is extremely advanced for San Francisco before 1900. She said the city's documented water infrastructure from that era shows significant variation, typically 3 to 8% deviation in slope, with irregular settlement causing additional problems. This is engineering quality work. Alternative researchers who study Tartarian infrastructure argue that such conduits were part of hydraulic bridge networks used for pressure regulation across underground systems. The theory suggests these were not simple water lines but integrated components of larger networks designed to manage flow across urban areas before modern plumbing. Inside the conduit, partially embedded in sediment, I found a metal fragment approximately 8 centimeters long. I photographed it and sent images to a metallurgist at UC Berkeley. His analysis indicated composition consistent with 18th or early 19th century European industrial alloys, iron with trace copper and manganese, not typical of West Coast foundry work from that period. A conduit that predates the building, unrecorded in city maps, engineered with precision that should not exist, and containing metal fragments too advanced for the region's documented industrial capacity. The contradiction grows with every measurement I take. Breaking through the southern buttress required permission from both the building owner and the city's Historical Preservation Office. When approval finally came, after 3 months of paperwork, I hired a contractor experienced in historical restoration. We removed bricks carefully, documenting each layer. Behind the buttress was a deeper level, a buried chamber nearly 2 meters below the existing vault floor. The air that emerged was stale, undisturbed for decades. Inside, I found more arches extending southward, more perfectly cut brick showing no tool marks consistent with 1800s masonry techniques, and a circular aperture in the floor that looks unmistakably like a pressure dome anchor. The aperture measured 60 centimeters in diameter, lined with fitted stones cut to identical dimensions. The fit was so precise that mortar had been unnecessary between some joints. Pressure domes appear in Tartarian architecture across Central Asia and Eastern Europe, documented in engineering surveys from the 1820s through the 1880s. These structures were thought to regulate subterranean hydraulic flow, using domed chambers to manage pressure fluctuations in underground water systems. The circular apertures served as anchor points for mechanical components that have since been removed. A 1932 renovation report, previously overlooked in the archives, described this lower chamber as non-essential sublevel filled with debris for structural stability. But when we cleared the fill, we found loose soil, not construction rubble, no broken brick, no mortar fragments, just soil loosely packed, showing no compaction. The soil showed no settlement layers, no stratification that would indicate decades of gradual accumulation. Someone had filled this space deliberately and recently, likely during the 1932 renovation itself, using clean fill soil. At the chamber's southern end, we found the outline where a mechanical component had been removed. The impression in the surrounding brick was circular, approximately 1.2 meters in diameter, with mounting points still visible. 4 bolt holes, perfectly spaced, still threaded despite corrosion. Someone buried this sublevel on purpose, and before that, someone removed its machinery with precision and care, but it never was reinstalled. Using ground-penetrating radar scans provided by a local historian researching San Francisco's buried infrastructure, we identified 3 additional arches extending eastward from the Ordifred Vault, all beneath streets, built atop 19th century landfill. The ground-penetrating radar data shows these arches connecting to the 1853 seawall footprint, suggesting an entire substructure existed before the landfill expansion. Their alignment is linear, perfect, and extends at least 40 meters beyond the building's current foundation. The spacing between arches remains consistent, 4.7 meters, identical to the vault I documented. This pattern matches known Tartarian bridge grids documented in old Eurasian cities, networks where underground arches distributed loads across unstable ground and often integrated with hydraulic systems for water management and pressure regulation. Even mainstream scholars acknowledge the anomaly. A 1998 San Francisco ground-penetrating radar survey report states that multiple subsurface vaulted structures were detected beneath the Embarcadero corridor, that construction predates the documented landfill timeline, and that purpose and origin remain unknown. The report recommends further investigation. The report's lead researcher, Dr. James Morrison, a civil engineer from Stanford, noted that these are not isolated foundations but interconnected systems, and that the engineering sophistication suggests coordinated planning on a scale inconsistent with mid-19th century San Francisco's documented capabilities. If this was not a single bridge but part of a larger pre-existing network, then the implications expand significantly. The entire waterfront may rest atop infrastructure inherited from something older, something built before the gold rush, before American settlement, before the historical record begins. The ground-penetrating radar scans show the easternmost arch terminating beneath what is now a cafe on Battery Street. According to the scan data, a sealed chamber exists directly under the building's foundation, approximately 3 meters below the basement level. I contacted the cafe owner. He knew nothing about subsurface structures. He recalled that during a 2003 renovation, workers encountered old brickwork they could not explain. They consulted with the city, and the recommendation was to seal it and pour concrete. Historical preservation said it was not significant enough to warrant investigation. The pattern continues: discovery, confusion, sealing, silence. Renovation photographs from 1974, archived at San Francisco Heritage, show workers removing a massive iron apparatus from beneath the Ordifred building's eastern wall. The component appears gear-like in structure, heavily corroded, and significantly larger than any equipment listed in the building's 1907 construction inventory. One worker's journal, donated to the archive in 1989 by his widow, describes the removal. old iron machine, heavy as sin. Took 4 men and a winch to pull it out. No idea what it did. Supervisor told us to scrap it. Never saw anything like it in 40 years of construction work. The gears were cut precise, even under all that rust. The mechanism's outline in the photographs suggests it may have been part of a hydraulic pressure system. Gear teeth are visible along one edge, precisely cut despite heavy corrosion. The mounting points show wear patterns consistent with rotational movement. This was a working component, not decorative ironwork. I compared the photographs to diagrams of Tartarian hydraulic machinery documented in 19th century engineering texts from Eastern Europe, particularly a Russian technical manual from 1867 covering subterranean water regulation systems. The similarity is striking. Several texts describe pressure regulation mechanisms installed in bridge substructures to manage water flow through underground channels. But why would a bridge-like substructure require complex machinery? The most coherent theory from Tartarian research suggests these were not simply bridges, but integrated hydraulic systems, infrastructure designed to move, regulate, and distribute water across urban areas using gravity and pressure rather than pumps. The machinery would regulate flow rates, prevent pressure surges, and maintain consistent distribution even as demand varied across the network. The 1974 photographs show the mounting points after removal. They remain perfectly aligned, showing no degradation or movement despite seismic activity and settlement. Whatever this mechanism was, it had been installed with precision and maintained structural stability for over a century before being extracted and destroyed. The worker's journal entry ends seemed like a waste. The ironwork was still solid. Could have gone another 100 years if anybody knew what it was for. But nobody did, so they scrapped it. By layering every archival document, photograph, blueprint modification, and physical measurement, the narrative becomes increasingly difficult to reconcile with official history. The timeline shows clear contradictions. The 1853 shoreline maps indicate landfill, where the Ordifred building now stands, yet the 1892 photographs show arches already present before major expansion. The 1907 building incorporates structures the architect never documented in submitted plans. The 1957 renovation removes ironwork nobody can identify. The 1974 renovation extracts machinery with no listed purpose. The 1998 ground-penetrating radar survey confirms an extended vault network predating all recorded construction. Present-day vault geometry matches bridge patterns documented across regions once labeled Tartaria, identical arch radii, identical buttress spacing, identical hydraulic integration systems, identical precision that exceeds documented period capabilities. I cannot explain how precision geometry appears in an era before standardized engineering education. I cannot explain how identical architectural signatures span continents, separated by oceans without documented contact. I cannot explain why every renovation systematically removes components while sealing chambers, why machinery is extracted and scrapped rather than studied. Official history states the Ordifred building was constructed in 1907 on landfill placed after 1853. Physical evidence suggests it was built atop infrastructure that predates the city's American settlement. The contradiction is irreconcilable without fundamentally revising our understanding of San Francisco's construction timeline. What grew beneath this building isn't consistent with known San Francisco construction methods. It mirrors a global architectural signature often attributed to a suppressed Tartarian engineering tradition, a civilization whose existence mainstream scholarship disputes, but whose architectural DNA persists in buried structures worldwide. I cannot prove who built it. I can only document what remains: precision beyond documented capability, hydraulic systems beyond recorded need, systematic erasure across multiple renovations, and silence in official records where there should be curiosity. The deeper I examine, the less the official narrative holds. Something was here before. Something was removed. Something was deliberately forgotten. One last archival photograph remains in the city archives, mislabeled and overlooked for over a century. In a folder marked Miscellaneous Harbour Views, 1860s, I found a photograph with no precise date beyond around 1860. It shows the waterfront decades before the 1906 earthquake, decades before the Ordifrid building existed. The image quality is poor, an albumen print faded and damaged, with visible water staining along the edges. But in the background, faint and blurred, yet unmistakable, stands a multi-arched stone bridge exactly where the Ordifrid building is now. The bridge spans nothing. It does not cross water. It does not connect two elevated points. It leads from the shoreline directly into the hillside and then vanishes into the slope, as if the earth had swallowed it. The arches are visible, at least 5 spans clearly defined, possibly more obscured by the image's degradation, before the structure disappears into earth and vegetation. I had the photograph analyzed by a specialist in 19th century photographic processes at the California Historical Society, Dr. Ellen Morse. Her assessment was that the print is consistent with the 1860s albumen printing techniques based on paper degradation patterns and chemical staining. There was no evidence of later manipulation or double exposure. The structure appears to be original to the image captured during initial exposure. Researchers who study Tartaria call these land bridges. They are engineered structures meant to integrate with hydraulic networks rather than simply cross obstacles. The theory suggests they functioned as pressure distributors, routing water through underground channels while maintaining structural support for surface loads above. To later observers who did not understand the subsurface networks they served, they would appear purposeless. If this photograph is authentic, and expert analysis suggests it is, then the structure beneath the Embarcadero is not a repurposed basement or forgotten foundation. It is the remnant of a bridge older than the modern city, a bridge built before American settlement, before the Gold Rush expansion, before the historical timeline acknowledges advanced infrastructure in this region. We covered it, we built over it, we buried it completely with landfill, we constructed new buildings atop its foundations, we forgot it existed. But the bridge never disappeared. It is still there, beneath the streets, beneath the buildings, waiting in sealed chambers and buried vaults. One sealed chamber remains unexplored beneath the Battery Street Cafe, its entrance marked only by a perfect stone arch, a signature found across what old maps once labeled Tartaria. The investigation ends here. The structure continues silent and patient beneath the city's streets.